So in chapter 2.2 is models and applications. So we're going to be doing some problem solving with linear equations. We're going to be given a word problem, and we're going to have to solve the word problem by creating a linear equation and then solving it. So let's jump right into examples here. So the average yearly salary of a man with a bachelor's degree exceeds that of a man with an associate's by $25,000. The average yearly salary of a man with a master's exceeds the associate's by $45,000. And combined, the three men earn $214,000. We want to find the average yearly salary of all three of these levels of education. So what you want to do when you start these is you want to let the variable equal something. So we're going to have x as our variable. So we have three different things here. We have bachelor's, associates, and masters. So we can let x equal the average salary for an associate's degree. So the reason why that one is just the x is because the other ones are based off of that. So the reason is, or explaining why that is, if we look at the bachelor's degree, the bachelor's exceeds the associates by $25,000. So that means the bachelor's will be x plus 25. So I'm just going to use 25 representing 25,000 here. So x plus 25 is going to be the average salary for the bachelor's degree. And now for looking at the master's exceeds the associates by $45,000. So once again, this is going to be in terms of the associate, so it's in terms of x. It's going to be x plus 45. Okay, so if the associate's degree earns x, bachelor's earns x plus 25, and master's earns x plus 45. So now we want to create an equation based on the fact that combined they earn $214,000. So combined means that it's going to be added. So this means that x plus x plus 25 plus x plus 45 equals 214,000. So associates plus bachelor's plus master's equals 214,000. And now we're just going to solve this linear equation. So it's going to be x plus x plus x, which is 3x. 25 plus 45 gives us 70. And we have to subtract 70 on both sides. So we get 3x equals 144. Divide both sides by 3, and we get x equals 144 over 3, which is 48. So for these word problems, we have to make sure that we're answering the question. We want all three of these. We want associates, bachelor's, and master's. So actually answering the question here, I'll set up a little answer over here. So for the associates, we know that that was our x value, which is what we solved for, and we got 48,000. So this answer is going to be 48,000. And for the bachelor's, that was our x plus 25, which is 48 plus 25, which is 73. So that's 73,000. And lastly, for the master's, we knew that that was x plus 45. So that's 48 plus 45, which is 93,000. Okay, so those are our final answers for this one. Okay, and the next one. We have a toll on a thruway costs $7. Commuters who use the toll frequently have the option of purchasing a monthly discount pass for $30. If they purchase that discount pass, the toll is only $4. So we want to know for how many toll crossings per month will the total cost without the discount pass be the same as the total cost with the discount pass. Okay, so here let's let X equal the number of toll crossings. And that's going to be toll crossings per month. So we want to come up with an equation where one side of the equation is without the discount and the other side is with the discount. So if we want to do it without the discount, it is the toll cost $7. So that's without the discount. So that means every time they cross the toll, $7. So it's going to be 7x. So this represents the cost without the discount. So if you went across once, it would cost $7. If you went across twice, $14. 3 times would be $21, and so on. So if you do it with the discount it is $30, and then it's $4 for every time you cross it. So you give them a flat rate of $30, and then it's $4 for every time you cross it. So that's going to be 4x plus 30. So the 30 does not depend on how many times you cross it. So that's why it does not have an x being multiplied. It's a flat rate of $30 plus $4 for every time you cross it. So this side is the cost with the discount pass. Okay, so now all we have to do is solve that. And it's going to be 7x minus 4x, or 7x equals 4x plus 30. So we're going to subtract 4x on both sides. And we get 7x minus 4x is 3x equals 30. Divide both sides by 3. And we get x equals 30 over 3. So x equals 10. So now make sure we're answering the question correctly. We want to know how many toll crossings per month will they be the same? So that is our x, so this is our answer. So we could say that the cost will be the same after 10 monthly toll crossings. Okay, so in this case, it would be worth getting the discount pass if you were crossing through that toll more than 10 times per month. Okay, so now let's do some questions with percentages. So we're going to be subtracting a certain percentage from an amount or adding a percentage to an amount. So if we're subtracting a percentage, technically these are the same exact formula here. Say we're subtracting a percentage, so that would be considered something like you can think of it as like a sale price if something's on sale. It's going to be the original price minus the percentage off. So in order to find a percentage off, it's going to be the percentage that's being subtracted as a decimal. So just remember that we're converting percents to a decimal. You have to move the decimal 2 to the left. So to find a percent of a number, you multiply the decimal form times the original price. That's going to equal the sale price. If we're adding a percentage, it's going to be the original price plus the original price times the percentage. And that'll give you the new price. So we're either adding the percentage or subtracting it. Same exact equation, one's addition, one's subtraction. Okay, so let's see an example here. So we have a store is having 25% off on sale on TVs. We want to know the sale price for a TV if the original price is $800. So essentially we're saying that we have an $800 TV and we're taking 25% off. What is the new price? So this is going to be, let's let X here be the sale price, which is what we're looking for. So the formula we'd be using is going to be that first one. We are subtracting a percentage, right? Because we're trying to find a percentage off. So you can memorize those formulas up there, it's good just to think about what you're actually doing. So X is going to be the original price minus 25% of 800. 25% of 800 is 800 times 0.25. So 25% as a decimal is 0.25. So this is going to be 800 minus 200. 800 times 0.25 is the same as 800 times 1/4, which is 800 divided by 4, which is 200. So this is going to give us 600. So that means the sale price of the TV is $600. Okay, so for the next one, your local computer store is having a sale on computers. After a 40% price reduction, you purchase a computer for $276. You want to know the computer's price before the reduction. So now we are looking for the original price. So based on the formula we're going to be using, it was the sale price, which is what we got the computer for. It equals the original price minus the original price times the percent off. So percent off is the same thing as the percentage subtracted or the price reduction. Those all mean the same thing. So the sale price is what we got it for. We got it for $276. We're looking for the original price, which we're going to use an X for, minus the original price, which is an X, times the percent off, which was 0.4. So 40% as a decimal, move the decimal 2 to the left. That will give us 0.4. I'm going to write this like this, 0.4x. Okay, so once you have this set up, all we have to do is solve this now. So this looks a little bit trickier than it is. X minus 0.4x, that is just 1 minus 0.4. These are like terms, so we can combine them. 1 minus 0.4 is 0.6. So this is going to be 276 times 0.6. So what we could do if we were using a calculator, you could divide both sides by 0.6. Or you could say that this is 276 equals, this is the same thing as 6 over 10 times x as a fraction. So when you're solving it this way, you could multiply both sides by the reciprocal. So this would be 10 over 6 times 276 equals x. This would give us x equals 460. Okay, so that's one way to do this, by doing it kind of by hand. But if you're using a calculator, you would divide both sides by 0.6. And we get the same thing. We get x equals 460. Okay, so this is the original price. So this is money. So we would say the original price. The original price was $460. Okay, for the next thing. So suppose you're out to dinner and your bill comes to $52 without tax. If there's 10% sales tax, we want to know what is the total cost of your bill. Okay, so all we have to recognize what we're doing here is that we are adding 10%. So if we're adding 10%, that means we're going to be adding a percentage here, obviously. So we're looking for the new price. So I'm going to let x equal the new price that we're looking for, the total price. So the formula that we're going to have set up is going to be the new price. The new price equals the original price plus the original price times the percentage added. Okay, so this is going to be X equals the original price here is just the total cost of the bill without the tax. That's going to be 52 plus the original price, 52, times the percent being added as a decimal is 0.1. So 10% as a decimal is 0.1. So once again, if you, just so you don't have to memorize the formula, it's the original price and you're adding 10% of the original price to it. So hopefully that makes sense without having to memorize it. So simplifying this, we get X equals 52 plus 5.2. So X equals 57.2. So this means that the total cost of the bill is $57.20. Okay, so one more of these percentage ones, and then we'll just do two other formula-based ones. So suppose you're out for dinner and your bill comes to $37 without tax. If the total bill with tax is $42.50, we want to know what is the sales tax. And we're going to round this answer to the nearest tenth. I'm actually going to change this to round to the nearest hundredth. Okay, so setting this up here, we have X is what we're looking for. So it's going to be X is the sales tax. And setting up an equation, it's going to be, this is going to be a percent added question. So it's going to be the new price equals the original price plus the sales tax. So plus the original price times the sales tax percentage. So I actually need to change that because that's what the question should be asking for. So we're looking for the sales tax percentage. I just forgot to include it in the question here. So let me just add it right up here. Okay, so the wording was just, I said it worded it incorrectly. If we were looking for the sales tax, technically it would just be $42.50 minus $37, which would be too easy. We're looking for the percentage for the sales tax. So plugging in our values here, the new price that we got was $42.50. The original price was $37. So it's 42.5 equals 37 plus 37 times X. So solving this for X now, we're going to subtract 37 on both sides. And we get 5.5 equals 37x. Divide both sides by 37. And rounding, the 37s cancel off. Rounding this to the nearest hundredth, we get 0.15. Okay, so let's write the answer as a percent. So that means the sales tax percentage is about 15%. Okay, so to write that 0.15 as a percent, we just had to move the decimal 2 to the right. Okay, so here I just put a bunch of formulas for different shapes. So we have our two-dimensional shapes in the top row, our three-dimensional shapes in the bottom row. So for the two-dimensional shapes, we have area and perimeter. For the three-dimensional shapes, we have volume. We could also have surface area for those if we wanted to. So we might need these for the next problem here. So the length of a football field is 200 feet more than the width. If the perimeter of the field is 1,040 feet, we want to know the dimensions. So we're looking for the length and the width. So let's set up a picture. So we have a rectangular football field here, and we can say that this is the width and this is the length. So this would also be the length, and this would also be the width. Because it's a rectangle, I'm just not going to write it. So we know that the length is 200 more than the width. So we could actually rewrite the length as 200 plus w. Okay, so setting up an equation here, we need the perimeter of a rectangle. The perimeter of a rectangle is perimeter equals 2L plus 2W. That's just the outside added all together. So it'd be W plus L plus W plus L. So P equals 2L plus 2W. And let's plug in our variables that for what we know. We know the perimeter is 1040. So instead of using L, we're going to replace it with 200 plus W. The reason we do that is because when we finish off this equation now, we have one equation with one variable, so we can actually solve for the W. If we did not plug in for L, we would have one equation, two variables, and we wouldn't be able to solve for it. So solving this for W now, we have to distribute the 2, so 400 plus 2W plus 2W, and combine like terms on the right. We get 400 plus 4W. So now all we have to do is subtract 400 on both sides. So subtracting 400 gives us 640. Divide both sides by 4, we get W equals 160. So making sure we're answering the question, this is we're looking for the length and the width. That was just the width. So we have the width is 160 feet. So 160 feet. And for the length, we know the length is 200 feet more than the width. So that's 200 plus 160. So that's going to be a length of 360 feet. So it's a width of 160 feet and a length of 360 feet. So let's do one more here. So a Coca Cola can has a height that is 4 times the radius. If the volume of the can is 400 cubic centimeters, find the radius and the height. Assume the can is a circular cylinder. And as put a note, this is not a linear equation. Every other equation we've done is linear. This one is not. So let's go up to these formulas here. So a circular cylinder is right here. So that does, taking a look at it, that does kind of resemble approximately what a pop can would look like. So the formula for this is volume equals pi r squared h. So the formula we're going to be using is volume equals pi r squared h. So once again, pi is approximately 3.14. So this one will obviously need a calculator for. So let's write down what we're given. We're told that the volume is 400 cubic centimeters. I'm going to leave out units when I'm plugging everything in. So it's cubic centimeters because volume is units cubed, because it's 3 dimensions. And we're also told that the height equals 4 times the radius. So we know the height is 4 times r, so it's 4r. So let's plug in these values and see what happens. So instead of v, we have 400 equals pi times r squared. We know that h is 4 times the radius. So we can simplify this because we can say that 400 equals pi, I'm going to write this a little differently. I'm going to write the 4 out front. 4 pi r squared times r is r cubed. So now we're solving this for r. So just remember that pi is a number here. So divide both sides by 4r, or 4 pi, sorry. Divide by 4 pi. So 400 divided by 4 is 100. So that's 100 divided by pi equals r cubed. So if we are solving for r cubed here, what we have to do is take the cube root of both sides. So this is when I mentioned that it's not linear. If something is cubed, if the variable is cubed, it's not linear. Okay, so taking the cube root of both sides, this is when you'll need the calculator, obviously. The cube root and cubing something cancel each other off, which is why we did it. So we end up getting r equals the cube root of 100 over pi. So type this into the calculator and just recall that if you want to type this in the calculator, if you have the cube root of something, you could either use that notation in the calculator, or you can raise it up to the 1/3 power. So they mean the exact same thing. So typing that in, we end up getting a radius is 3.2-ish, and the units are centimeters. I'm just going to leave it as 3.2. Okay, so to find the height, we know the height is 4 times the radius. So we know that h equals, right below it, h equals 4r. So h equals 4 times 3.2. So the height is going to be about 12.8. Okay, so we have the radius of the can is r, which was 3.2 centimeters, and the height was h, which we just found was 12.8 centimeters. So these numbers seem pretty reasonable, so we probably didn't mess anything up here. Okay, so a little bit more complicated with that one because it was not linear. We had to take the cube root, but it's still doable. You just have to have that formula and plug in your values. Okay, so that's it for this section.